Hey guys, Mr. Middleton here. Today we're going to work on trig word problems. At the end of this video, you should be able to differentiate between the angle of depression and the angle of elevation, and you should be able to accurately set up and solve word problems involving trig. Okay, so let's first talk about angles of depression and elevation. In the picture above, angle 1 represents the angle of depression from the mountaintop to the person. Okay, and notice depression in this case just means looking down. Okay, so it's how much you have to look down. If you're from the mountaintop to see the person, you'd have to look down, whatever, angle 1 degrees. Okay, angle 2 represents the angle of elevation from the person to the mountaintop. Okay, so again, how much would this person have to look up to see the mountaintop? The angle of elevation from the cabin to the person is represented by angle 4, and the angle of depression from the person to the cabin is represented by angle 3. Okay. Quick note that both the angle of elevation and the angle of depression both are formed by a horizontal line. Okay, and what that means is horizontal line. What that does is it helps us to set up our problems as we talk about the angle of elevation and depression. So notice that for the mountain, actually let me just draw a triangle here. Okay, in our story problems we're going to have to set up these angles given some different descriptions, and what happens a lot is if I give an angle of depression, let's say I say the angle of depression from a bird to a flower is 30 degrees. What people like to do is they like to put this as 30 degrees, and that's not true. The angle of depression is from the horizontal line. Okay, so if I said the depression was 30 degrees, that would happen here. This angle would not be 30 degrees, then it would be 60 in this case, but we'll get to that later. Okay, so the angle of depression is formed by a horizontal line. Okay, the dotted lines are all horizontal, and so they are all parallel. Okay, because they're parallel, that means that the measure of angle 1 is congruent to the measure of angle 2, and angle 3 is equal to angle 4. And that's all because of alternate interior angles theorem from first semester. Okay, this is always the case. Always the case. Okay. Alright. Sorry about this pen is not allowing me to write as well as I usually do. Hopefully it's still legible. Okay. Alright, so now with that out of the way a little bit, let's go through and set up some of these problems so that we can solve them and get on our way with this trig stuff. So our first problem says a pilot sees a life raft at 26-degree angle of depression. If the pilot's altitude is 3,000 meters, what is the plane's actual distance to the life raft to the nearest meter? Okay, so we got a pilot in a plane. He's here. Okay, he sees a life raft down here somewhere. Okay, 26 degrees of depression. Okay, so I'm going to draw my triangle. So 26 degrees of depression, remember that means how far down is he looking. This is 26 from the horizontal. Because I know that all the angle of depression and this angle of elevation is the same, I'm going to write this as 26 degrees. Okay, the pilot's altitude, straight up, is 3,000. What is the actual distance from the life raft to the nearest meter? I'm going to say a plane's distance is this line, right? So I'm going to call this x. So from the angle that we know inside the triangle, 26 degrees, we have the opposite and the hypotenuse, and so we can set this up with sine. So sine of 26 equals the opposite 3,000, over the hypotenuse x. Okay, now we'll solve for x. X will equal 3,000 over sine 26. So 3,000 divided by sine 26. And that will give us 6,843. So it's to the nearest meter, so 44. Meters. Okay. All right. Backside says a surveyor stands 200 feet from a building to measure its height with a 5-foot surveying tool. The angle of elevation from the top of the tool to the top of the building is 35 degrees. How tall is the building to the nearest tenth of a foot? So you got a tool, it's 5 feet tall. Okay, it's standing 200 feet from a building. Oh, gotta go straight lines. Okay. Here's our building. Angle of elevation to the top of the building is 35 degrees, okay? And so, I'm going to draw this as 35 degrees. Okay, we want to know how tall the building is, so I want to find out this x value. Alright, a couple things to notice here is that 200 feet away from the building. Our tool is 5 feet off the ground, so that's what this extra 5 is. When we find x from this triangle, okay, we will have to add this 5 feet to it. Okay, so now we're given opposite side, that's x, that's what we want to find. Adjacent side is what we know, and so we'll say opposite and adjacent, that's tangent. Tangent of 35, the angle that we're viewing, equals the opposite x over the adjacent 200. Multiply both sides by 200, so 200 tangent 35 equals x. So 200 times tangent 35, and that gives us 140.0. Okay, so this is 140.04, so 0. And then remember, we need to add this 5 feet to it. So 140 plus 5, I'll just do this in the calculator. I knew what that was. Okay, 145 feet. That's how tall it is. Okay, you see that the answer for number 3 is 386. I would like for you guys to set up the diagram and the equation for me and bring that in to me tomorrow. Okay, with your completed notes. All right, we got 2 more examples here. Number 4, the Americans with Disabilities Act states that wheelchair ramps can have a slope no greater than 1/12. What is the biggest angle of elevation to the nearest tenth of a ramp with this slope? Okay, so ramps will look something like this, right? Okay, it says the ramp can have no greater slope than 1/12. That means it rises 1, runs 12, and we want to know the angle of elevation. What's the biggest one that we can have? So notice here that our variable is an angle now. Okay, we're given the opposite side and the adjacent side from that angle. So opposite and adjacent is tangent, so we can say tangent x equals opposite over adjacent, 1/12. And now we need to find out what x is. Okay, remember that we'll do that by using inverse tangent. That will help us to get rid of tangent on this side. And so we'll take the inverse tangent of 1/12. And that will give us 4.76 degrees. Okay. Our directions tell us to round to the nearest tenth, and so initially we'd say 4.8 degrees, but the direction, or the Americans with Disabilities Act says it can't be any greater than 1/12. So if we do 4.8 degrees, that'd actually be greater than 1/12. And so to the nearest degree we should do 4.7. Okay, so a little bit of technicality there. Rounding it would tell us to go 4.8 degrees, but the Americans with Disabilities Act would tell us that that's too steep, so got to take it down. Okay. All right. Finally, pilot is descending towards a runway at an angle of depression of 3 degrees. Again, my plane. Okay. Okay. With the angle of depression of 3 degrees. Okay. His current altitude is 2,714 feet above sea level. Okay, so his current altitude is 2714. Okay. If the runway is 1,007 feet above sea level, how many miles is the plane away from the runway? So, our runway, they said, was 1,007 feet. This guy is 2,714 feet. Okay, and so what we're going to do is we're going to say, okay, what is this actual height, actual distance? We got 2714 minus 1007, and that gives us 1,707 feet. So we've got our runway here, 1,007 feet above sea level. We know how far away we are. That's this value x, the hypotenuse in this case. And so we have the 87. Okay, so from our vantage point, we know the adjacent. We are trying to figure out the hypotenuse. And so we can use cosine. We'll say cosine of 87, okay, equals the adjacent 1,707 over the hypotenuse x. Okay, so I'll multiply both sides by x, divide by cosine 87. I have 1,707 divided by cosine 87. That should give me a pretty big number. And that will be 32,616 point, we'll say 20 feet. Okay. Now the directions want us to know how many miles is the plane from the runway. So, not too bad if you know miles. Miles, 5280. 5 tomatoes, I don't know why that works. 5280. And so, to the nearest hundredth of a mile, it's 6.18 miles. Okay, so adding a little bit to the trig functions there with these story problems, but hopefully not too much for you to be able to take what you know and apply it to it. All right, see ya.